I'm Deepika Singh, an e-learning specialist and subject matter expert. Coming to our computer architecture part, we are going to discuss a very important topic this time, that is a pipelining in computer architecture. So let's explore about it. In computer science architecture, pipelining is basically a technique used to increase the instruction throughput. Throughput means how much the numbers of instructions that can be executed per unit time is called instruction throughput. So the pipelining helps to improve the instruction throughput. So it's by dividing the processes of a single instruction into multiple stages. Actually, instead of executing one instruction per at a time, it divides the instruction in a certain parts, and then that particular parts are being executed. And each and every part of an instruction is executed in the phase, and each and every phase is responsible for executing its role, which I'm going to explain you through instruction cycle. So each stage, so pipelining basically improves the stages. It improves the throughput of the complete instruction, and it improves the it improves the complete timing and efficiency of the complete process. So before moving further, let's see its cycle. You can see, first of all, moving to the cycle, you can see here the clock. For every phase a particular timing is been given, and so whenever the process starts, the clock moves along with that. So here the first phase for the first phase is instruction fetch. Here what happens in instruction fetch is basically, instruction fetch is the instructions are being fetched in the stage. Here you can see the instruction comes through in, and then it is after the instruction is fetched, and it is being kept in a buffer register R1. Buffer, what is the buffer? Buffer is a temporary register. Then in the second phase, what happens in the second phase? The instruction is being decoded. Decoded is means, like, whenever it comes, the instruction comes decoded, it must be encoded, it must be put in another form. So according to the requirement, according to the form, so that it can be executed. So in the proper format, it has been decoded. Decoded means it is converted into a suitable form so that it can be executed, so that the information can be understood. So this is basically called, and after doing this, it is being kept in buffer register R2. Then in the third phase, you can see it is instruction execute. After decoding the instruction, so it comes, the processor understand what to do. So after understanding what to do, it executes the instruction. Then in the final stage, which is the fourth stage, what happens? The result of the instruction is being written in the proper format, so that the result can be transferred to the as an output. So this is all the instruction cycle. Now you have understood the cycle of instruction. Now in this part, you're going to understand about the types of hazards in pipeline. Hazard means the typical problems which people face while executing a instruction. So here the first type of hazard is data hazard. The data hazard occurs when the instruction depends on the results of previous instruction. Like suppose in pipelining, when one part will come, it becomes an input for the second part. Similarly, the cycle. I'm just explaining you the result of first pipeline will become the input of the second pipeline. So this is something that happens. So if the answer of, or the data of the previous pipeline is not perfect or is not good, then the pipelining result cannot be executed. So I'm just giving you one example. If instruction 1 is calculating a value and instruction 2 needs that value to execute the result, then instruction 2 cannot be proceeded until instruction 1 finish. So these types of techniques, basically, if the part 1 is not being properly proceeded, then it will create a problem for the execution of the second part. So this type of problem is called data hazard. Then the second type of problem is control hazard. Control hazard occurs due to execution of branch or jump of instructions, where the next instruction is to fetch it is uncertain. Like now, what happens, like in the second part, what I'm telling you, if in the second part instruction is depends upon the branch or jump instructions. branches, like it is going or not going. If in conditions, you must be seeing the programs. If this will come, if this happen, then this will execute. If this will happen, then this will happen. So automatically it will jump to the condition. But if something is not happening, then this particular kind of function is not going to execute, or this will not execute in a proper way. That branch or jump instruction is not been executed. So branch prediction and speculation executions can help mitigate control hazards. So if we but how can we able to control these things? We can, if we control, if we properly define jump functions and everything, then if we can able to control this kind of problem. Then the last type of problem which eventually we face is structural hazard. Structural hazard is, you are getting, you can understand, like it is a problem when the complete program for execution of the pipelining is not been properly written, or when multiple instructions require the same hardware resource at the same time. It occurs like there are multiple instructions which require the same resource, same hardware resource. So each and every one is be dependent for the free processing. Until the one will not free, then it cannot be executed. So this type of things can able to erase can able to raise the problem of structural hazard. So these are less common modern designs in resource are generally duplicated and prevent conflicts. Like with these days, most of the computer hardware's programs are written so that this kind of problem does not hazard, because microprocessors are coming out, and for each and every type of particular processor, the resources being provided. So modern things are coming, but still in the previous systems, this kind of problem do occur. But in generally, it can happen. But for your information, you should know this thing. First, we're going to understand various types of pipelining. So, the first type of pipelining is scalar pipelining. It is what is scalar pipelining? It is a one in scalar pipelining. One instruction is proceeded in each stage at a time. Instructions are issued one after the another. The second type of pipelining is superscalar pipelining. What happens in superscalar pipelining? Multiple instructions are fetched, decoded, and executed simultaneously in different execution units. It is more advanced form of pipelining which significantly increases the instruction throughput. Now, the third type of pipelining is vector pipelining, which is a modern approach. It is applied in the processes dealing with the vector with the vector array data types, array, like in which where the executions, the multiple instructions can be executed at a time. So it is more advanced technique. So it is data types where the same operation is applied to multiple data elements in parallel, which I was discussing about the problem now. So that can be rectified through vector pipelining. So these are the types of pipelining: scalar pipelining, superscalar pipelining, and vector pipelining. Then the next, we are going to discuss about the pipelining performance metrics. Performance metrics are basically those features through which we can able to determine the performance, efficiency of the pipeline. So in it, the first thing is with the help of latency. So what is latency? Latency is this time. Latency is basically the time it takes for a single instruction to pass through the entire pipelining from start to finish, means from the instruction fetch to result writing. So how much time that particular pipeline is being taken. So this is called its latency. Then the next is throughput. The throughput is basically, it is the rate at which the instructions are completed. Ideally, pipelining can increase throughput to one instruction per cycle, assuming no hazards, without hazards, one instruction per cycle. So this is basically the throughput, how much the number of pipelinings can be executed at particular time. So this is called the throughput. So these are the pipelining performance. Now moving further, we are going to first of all understood about the key advantages of pipelining. The first advantage of pipelining is higher throughput. Higher throughput is throughput means maximum number of work can be done at particular timing. So this is a throughput. So this is the most important advantage of pipelining is higher throughput. Higher throughput means it can be done because multiple instructions are processed at same time. Multiple instructions means multiple work can be done in a single time. So obviously in a less time, more and more work can be done with the help of pipelining with the system. So through it increases the overall CPU performance. Then the next advantage is efficient usage of resources. Like their computer has its own resource, its hardware, its timing and everything. So with the help of pipelining, we can able to efficiently use that resources. So it can be used more efficiently since different stages. Why this? Because since different stages of different instructions can operate in parallel, that means continuously with along with one instructions. You must have learned about operating system, in which the timing is multiple processes can be executed by time sharing, and a lot of processes, and they all work in parallelly. For our computers, for our human being, since we feel that all the work is going on continuously, but it's a very small time slice for each and every process which has been given. So and according, like at 1 microsecond this particular process will execute, then second, then this will execute. But as a human eyes, we cannot able to observe these things easily. So that is the thing that happens. Then the next is key disadvantages. Along with advantages, the pipelining has some disadvantages also. So the first advantage is complexity. Still, pipelining is complex. So complexity, it is actually managing the hazards and ensuring instructions flow smoothly through pipeline increase design complexity, obviously, because covering out the complexities, covering out those kind of hazards, it requires a lot of complex problems. So this is something which is a key disadvantage of pipelining. And the next is pipeline stalls. Pipeline stalls is basically naturally it occurs when there is some kind of hazard. When pipeline faces some kind of hazard, then pipelining gets stalls. So it reduces the performance. So it requires, so this is also a research area, so a lot of research is going on to handle this. Now we have come to the end of this video. Thank you very much for seeing this video. Please give your feedback. In this video we have learned about the pipelining. So again, I'm just recalling all the things which we have learned. In instruction cycle, there is a fetch, decode, execute, and result writing. And then we have discussed the various types of our pipelining, their key advantages, disadvantages, performance metrics. All of these things we have covered in this video. So any kind of queries and other kind of topics, you can able to just give your comments, and what are the topics you want to learn, please give your feedback. Thank you very much. Happy learning.